Alright, today we're going to talk about enthalpy of formation. And you'll need to be able to calculate the enthalpy of formation for the test. You're going to use table 8.3 to get the values. And if you don't have the book and you can't look up table 8.3, it will be posted on eCourses. Under enthalpy of formation. So it'll be a resource. If you look for it, it'll be enthalpy of formation. And it'll be posted on eCourses. So let's get moving into what or how to calculate it. So I'm going to put up an equation. Silver solid plus 1/2 chlorine gas is going to equal silver chloride, right? And silver chloride is a solid. So we can look at this reaction. We can look at the table and notice the silver chloride has a value of delta H equals negative 127.1 kilojoules. Alright, so if I gave you this value, there's two ways to do this. One way is we put in 127 right here. Alright, and then these values are going to be 0 and 0. Right, and then if we calculate the delta HF, we're going to get negative 127.1 minus 0 minus 1/2 of 0, right? And the 1/2 matches over here. So this 1/2 came from here. Alright, the reason we're not using any other coefficients is because this is 1, and those are implied in this lower part. So now we're going to have the same thing, negative 127.1. Alright, so notice that basically when you have all elements, delta HF equals 0. Alright, so the enthalpy of formation for all elements is going to be 0. And it's really important to remember that. And now I'm going to give you a new problem that's going to test that understanding out. So this slide is going to be enthalpy of formation continued. And this time I'm just going to give you a basic reaction. And we're not going to look at the chart at all, but you should be able to figure out the enthalpy of formation for the element instead of for the reaction. So delta HF for, and I said element, but I actually meant NO2. Okay, so we're going to have N2 plus O2 equals NO2. And now I'm going to balance that where we're going to have 2 here, which means that we also have to have 2 here. And this is supposed to be arrow because it's a chemical reaction. And then this is going to be a gas, and NO2 is also going to be a gas. Alright, so now if you see the equation and they give you delta H equals 333.2 kilojoules, all right, and positive. So now, and actually, sorry, we'll do 66.4. All right. So now the question is, what is delta HF for NO2? All right. And you can do this by pretty much solving backwards. So we know that delta H equals the products equals the sum of delta H for the products minus the sum of delta H for the reactants, delta HF for the reactants, which means that if we plug in, we have positive 66.4 kilojoules equals X, which is what we want to know, right? Or equals delta H F for NO2, all right, minus 0 minus 2 or let's do this, minus 0 plus 2 times 0. All right, and so if we do that, we basically get 2 times delta HF of NO2 equals 66.4 kilojoules. Now you might have noticed I just added a 2 there, but that 2 is coming from the equation right here. All right, this 2 is coming from the coefficient of the equation over here. All right, and these are 0 because they come from elements. Elements delta HF equals 0. All right, so now we have 2 delta HF NO2 equals 66.4. So if we divide both sides by 2, we get the final answer, which is delta HF of NO2 equals 33.2 kilojoules. So you should know how to do that for the test, right? All you're doing is, remember, we're going to go in, we're going to put our products, our reactants, right? Products minus the reactants. And if we already have the delta H, if we already have this is going to go over here, right? So it's that simple. So even if you don't have the delta HF, you should be able to get it if you have the delta H. All right. So finding the delta HF is sort of this question, and you have to be able to do that, especially for a simple problem like this, where you have 2 elements and then you have a product.